Hello, students. Today will be a quick review over a topic you should have covered in a previous science class and even in math class, to be honest. But the one thing that we will kind of focus on is how to use scientific notation in your calculators, because oftentimes, somebody knows how to add and subtract numbers correctly, but then when they put it in the calculator, they don't do it right. So we're going to go over that specifically. So what exactly is scientific notation? It's just a way to express extremely large numbers or extremely small numbers in a shorthand format, right? In science, there's a term called a mole, all right? So what a mole is it's a unit of measurement. Just like if I were to say, what does 1 foot equal? Well, you guys would say 1 foot equals 12 inches. All right. Now, at one time in your history, in your lifetime, you had no idea what 1 foot equaled. All right. Someone had to tell you what it was. So here we have another unit of measurement. All right. We have 1 mole. What does 1 mole equal? We have to figure out what the smaller quantity is. Just like 1 foot was a large quantity and it was the equivalent to 12 inches. Well, 1 mole in chemistry is going to be 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21, 22, 23. All right, it's going to be that number. All right, then it's going to be that number of anything. Just like if you were to have 1 dozen, okay, if you have 1 dozen, you could say that you have a dozen eggs. You'd have a dozen people, a dozen computers. It doesn't matter. A dozen is a quantity. So if you have a dozen, that's going to be 12 of anything. All right. So if we have a mole of people, we have this number of people. If we have a mole of atoms of something, we have this quantity of atoms. See, so why in chemistry, why do we use this very, very large quantity? Because you can't deal with individual atoms. You can't say that you're going to work with a single atom of carbon, let's say. It's just too small. You can't see it. All right. So if we put this quantity of carbon atoms together, right? So if I have that number of carbon atoms, you would have 1 mole of carbon. All right, and on a triple beam balance, it would weigh 12.01 grams. All right, now, if you were to work with this value, you can't, more than likely, maybe your calculator can put in 6.022 and all those zeros and show it on the screen. Maybe it can, but I doubt the majority of our calculators are going to be able to do that. And then secondly, what's the chance that you're going to type in the number and either put in too many zeros or not enough zeros? All right. So in science, we will write this number in a shorthand method. All right. And that shorthand method is going to be scientific notation. You don't say laugh out loud. You say LOL. It's a shorthand. All right. So for this, the shorthand is going to be where we find the first whole digit value. My first whole digit value is 6. All right, so I'm going to put down here, we'll change the color, we'll go with blue here. We'll put 6. All right, that's the first whole digit number. And then after that, I'm going to put a decimal point. All right, we will then go ahead and put the remaining values that have whole digit numbers down. We do have to put down this 0. Okay, it would be what we'd call a significant figure. Remember that? We have a 2 here, and then a 2 here. So I'll put 2, 2. And this value right here, all of those whole digit values, those significant values, that's what we're going to refer to as the coefficient. All right. Now, each time that we remove these zeros over here, those are place values of 10. All right, so if those are place values of 10, what we have to put in here now is our power of 10. How many times did we move our place value 10 value, or a place value of 10? All right, now if our decimal was originally right here, what we'd have to do is count over all of these spaces until we got to where we put that decimal point. All right, so if I counted up all those zeros, what I'm going to find is that I would move the decimal to the left in that particular number 23 times. All right, so that's your scientific notation. That's the shorthand for it. So this right here, I'm going to put power of 10. It's our place value of 10 that we're moving it. How many times did you move that thing? Now, the one thing that you might be kind of wondering is what happens if we, let's say, have a very, very tiny number. All right, the amount of money that I have in my bank account, let's say. All right, so if you had 0.000000000, and I'll put 602 just for the sake of having a number. Okay, how do we get that into scientific notation? Well, it's the exact same thing that we had done before. We find the first whole digit value on the left-hand side, and then we write it down. That's our starting point for our coefficient. Put a decimal point, then we put the remaining values after that that would be significant. We'll then put in our power of 10 here, and we have to count how many times that zero or the decimal moved place values over. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9 place values. So we're going to have 9. Now, when you move the decimal point to the right, okay, you have to make sure that you put it as a negative power of 10. Okay, so it's going to be a -9 that we'd have moved it. Now, some people, they have troubles remembering how in the world do I know if it's going to be a +9 or a -9. Here's my kind of silly way of doing this. All right, so if you're looking at the palm of your right hand, all right, and you were to make a little, a gun symbol with your hand, or you point your finger out like this, all right, and you're going to see why I'm the world's greatest artist right here. If you're looking at the palm of your right hand, it can't be anything else. It has to be your right hand. If you're looking at the palm of your right hand and you put your thumb up into the, point your thumb upwards, all right, if the decimal, it's a horrible hand, all right, but if that's your hand, the palm of your right hand, and you put your finger out, which way is the thumb pointing? The thumb is pointing up. So if the decimal point goes to the left, then our value is positive for that exponent. All right, now what happens, though, if you move your decimal point to the right, as in this case? This is where it gets a little awkward because you have to turn your hand upside down. Now, again, you still have to be looking at the palm of your right hand, all right? But the decimal point, you can see here, you can see here it went to the right, okay? So if you're looking at the palm of your right hand, which way did the decimal point go? It went to the right. Now, your finger is like the little bullet of your hand pistol there, okay? And your thumb now, which way is it pointing? It's pointing down, and whenever you put your thumb downwards to somebody, that means that it's a negative sign. All right, see how easy that is? All right, enough of that silly stuff. Let's look at how you put this number into the calculator properly. All right, so I'm going to bring up my calculator. Yours will look a little different, but it's going to be the same. Every calculator has this button on it. All right, get out of the habit of using that stupid caret. All right, on your calculator you have the caret button, and I don't know why you use it. Carets They're for rabbits. Okay, you eat carrots. You don't use carrots for math, all right? Pet peeve of mine. All right, so what is the better way to use your calculator in terms of scientific notation to where you will never have a mistake? I can't tell you how many times bullheaded students want to use that caret button. They write out all the stuff correctly on their paper, and then all of a sudden they use that caret button and then they end up with the wrong answer. All right? Don't be that person. So let's see how you use that caret button correctly when you're adding and subtracting, multiplying and dividing with scientific notation. All right? So let's use that mole number or that value. So if you have 6.022 times 10 to the 23rd, and we're going to multiply that by let's pick another number. Let's go 1.2 times 10 to the third. All right. Now that would be a whole lot of zeros that you're putting into your calculator. All right. So what would be the way that we could express this on your calculator using scientific notation without using the caret button? All right. So we're going to first start off by putting in the coefficient. The coefficient is this value right here. So I'm going to go 6.022. Now, don't use don't do this. Don't put times 10. Don't do that. I hate it when I see people do that because you're going to mess up. All right. Instead, be smarter than that. All right. There is on every calculator an EE button. Now, yes, I pressed the EE button and only one E showed up. That doesn't mean I press it twice. All right. Don't ask me why people have programmed the calculators and it has the EE to represent this times 10, but it does. All right. So I'm going to say this clearly. The EE button on your calculator is the times 10. Okay? That's a whole lot easier to put that in. You press EE one time instead of putting in times 10. You're all about making work easier, so let's make work easier on yourselves. All right? So in the calculator, I have and I'm going to get rid of this. I have right now on the screen this value, and then I also have the E, which means that right there. I'm going to go and put in my power of 10. That's that 23, and that's what we have as an equivalent. This thing right here is now on my calculator screen. All right, we're going to finish up the rest of the problem here. So I now have to put in the times symbol. So I'll put times. And then I'll go ahead and start putting in that coefficient for the other number. So I have 1.2. Don't use the times 10. Don't use the caret. You're going to hear me beat that into your guys' head because you've been taught the wrong thing. So we're going to go times 10 or EE, right? And we'll put the 3. So now I have everything on that problem written into the calculator. I hit enter, and that's my answer. All right. There's no mistakes that are going to get made when you do it this way. You will 100% be guaranteed that you're doing it right. Mistakes come into play when instead of putting it in that way, you go like this. You go 6.022 times 10 EE 23. That's not right, because what this is going to do is it's going to take your 6.022, multiply it by 10, and then take and put an exponent of 23 onto that power of 10, and it's actually that would actually be 6.022 times 10 to the 24th. Don't do that. Okay. Now, I'm going to save you time. We don't need to go through and show you examples of all of the others like divide and divide and add and subtract, because the process is going to be the exact same thing. If we put in here a divided by, well, all that's going to be is we would say, oops, EE23 divided by, all right? And then we put in the 1.2, or we put in the plus, or we put in the minus. The big thing is for you to learn when you're using your calculator, this right here, that EE button is the exact same thing as you punching in this into your calculator. And what do we never use? Carets. Don't use the caret button in here. All right, just get rid of it. Forget about it. All right, we're finished up with this stuff. You're going to be working on now a review over not just the scientific notation, but you're also going to have significant figure review also. And we're going to be coming up on a test real fast. All right. So if you have questions on this stuff, make sure that you ask. If not, just go ahead and get it turned in and on Schoology, and we'll be all set. All right. Have a good one.